Bismillah ar-Rahman ar-Rahim. We'll start talking about this section, finding the volume. We have two sections. One is using the disk washer method, and the other one is using the shell method. So we'll talk about the disk method. Okay. So the idea is what? If we want to find the volume of a solid, or the solid generated by rotating a function or an area about an axis, either the x-axis or the y-axis, or something parallel to these two axes. Okay. So the idea is what? Now, if we want to find this is the solid of revolution, where I have a function. This is the function. This is f of x. Okay. And they have this strip, which is the most about this is we call it r of x, which we call it the length of this strip, which is in this case f of x minus 0. It will be. And then if we make the revolution, then I have what? Then we have a disk. I have a disk. And I want to find the area of that disk, which since this is R. So the area will be what? By R square. By R square. Okay. So the volume will be what? Will be the integral of that area, of the area of that disk. So how to find the volume? A sketch is your first step. And then we draw a line perpendicular to the rotating line at the point X. We have a point X, and then we draw this line. We draw this line. Then we have a formula for the area, which is the radius, R. In this case, it's only R of the disk in terms of X. So the area will be by R square. The limits of integration will be from here to there, or from A to B. And then we'll integrate to find the volume. Volume will be the integral from A to B by R square. Let me do an example. Find the volume of the solid formed by revolving the region bounded by the graph of this square root of sine x. This is the graph of square root of sine x. So, okay, let me do it again. Which is this. Something like this. Okay. And they want it from 0 to pi. Want it from 0 to pi. Okay. From 0 to pi. So do this line, this, and this is give me r of x, which is what in this case? R of x. In this case, it will be the function minus 0. F of x minus 0, which is square root of sine x. Okay. This is what I need. We need also to draw the line. Now we find the area. So the area will be what? A of x will be by r of x square. And that give me by sine x. Okay. That will be the area. The limits of integration, very clear because I have this line. I'll make it everywhere. So I'm going from 0 to pi. From 0 to pi. Then I have the volume. The volume will be the integral from 0 to pi. Okay. By r square. By r square. I'm doing this one in details. By r of x squared dx. Which is what? Integral from 0 to pi by sine x dx. And that give me what? That give me what's the integral of sine? It will be cosine from 0 to pi. And that, I know cosine, that will be minus pi, cosine pi, minus cosine 0, times minus pi. So it will be what? Minus pi, I'm doing it in details. Minus 1, minus 1. So the answer is 2 pi. That will be the answer. Okay, another problem. Find the volume of the solid formed by revolving the region bounded by the graphs. This is the graph. I have the graph here, but I want to do it again. So we'll show you how we start from scratch. I have this is 2 minus x squared, which is this parabola. Okay. And they have the function g of x equal 1. This is gx equal 1, y equal 1. We want to do this about this line. This will be my axis of revolution. By the way, here I have this one will be my axis of revolution. Okay. So now what will be r? I have this function. Now if I make the strip, is y equal 1. Okay, I have y equal 1. So we are talking about this area. Oh, there's no change the graph. Sorry. I'm talking about this area. This is the area. The region. This is the region bounded by the graphs of this and g of x equal 1, which is this is the region. So I need to find this point. I need to find this point also. How to find these 2 points? So I'll find points of intersection. This I equate the 2 functions. 2 minus x squared equal to 1. So I have what? X squared is equal to 1. So it means x equal plus or minus 1. So this is minus 1 and this is 1 for the x values. Okay. Now we'll make the strip, the line. We'll make the line. This is the line. I'll make this line. So this is an r of x. Since it's right away, it's on the axis of revolution. So this side will be what? F of x minus 1, which is 2 minus x squared minus 1, which is 1 minus x squared. Okay, so what will be the volume? The volume will be by integral from minus 1 to 1 of 1 minus x squared all squared dx. Okay, and that will be by, you need to open this, 1 minus 2x squared plus x to the power 4 dx. It's even function, so just to make the calculation easier, I can make it from 0 to 1, multiply by 2 of 1 minus 2x squared plus x to the power 4 dx. Yeah, to make the calculation easier. And that give me 2 pi times what? X, 2x cubed over 3, x to the power 5 over 5 from 0 to 1. Now that will make the calculation easy, because when I substitute by 0, I'm getting 0. So I have 1 minus 2 over 3 plus 1 over 5. That give me what? 2 pi 15. I have 15 minus 10 plus 3. That give me what? 2 pi times 8 over 15. Oops. So I'm getting what? 16 pi over 15. Yeah. Find the volume of the solid obtained by rotating about the x-axis. Okay. The region of this curve. So we'll start with the graph. This is square root of x. Okay. I want it from where to where? From 0 to 1. From 0 to 1. And this is my axis of revolution. This is my axis of revolution. Okay. So if you make a strip, when you make this line, I have this line. That line will be r of x, which is f of x minus 0 in this case. So r of x will be square root of x. And from where to where? From 0 to 1. So the volume will be pi integral from 0 to 1. What will be r square? It will be x dx. Okay. That will be what? Pi x square over 2 from 0 to 1. That give me pi over 2. And that will be the volume. Do another problem. Now I want to find the volume. Yeah, volume of the solid revolving the region bounded by. First, I need to find the region. Y equals square root of x. And the lines y equal 1. Y equal 1 will be where? Have y equal 1 means x equal 1. Somewhere here. And the line x equal 4. And the line x equal 4. So this is 1. This is y equal 1. This is x equal 4. Okay. So where is the region? We're talking about this region. This is the region. Okay. What is this point? This will be 1, huh? Y equal 1. With this, very clear x equal 1. Okay. Now we need to draw the line. Now find the region. Let me draw the line, which is this one. This will be my line. So this will be r of x. And it will be what? F of x minus 1. By the way, this is the line. This is the the line where I have the revolving, the axis of revolution. This is the axis of revolution. Okay. So it's y equal 1, the axis of revolution in this case. So r of x will be f of x minus 1. That will be f of x. That will be r of x. So r of x will be square root of x minus 1. This is r of x. So what will be the area? I need to find r of x square, then multiply it by, which is square root of x minus 1 square. So it will be the volume. The volume with the integral. I have, this is the area, so it will be from 1 to 4 pi and r square dx. That gives me pi, equal 1 to 4. What is this? X minus 2 root x plus 1 dx. So do the calculation. X squared over 2 minus 2 times 2 over 3 x to the power 3 over 2 plus x. This is I want it from where? From 1 to 4. Okay. We'll do the calculation. Don't forget the pi, huh? I have pi times all of this. So I have pi times what? 4 square, which is 16, 8, minus 4 over 3, times what? Square root of 4, which is 2, times 8. Plus 4, minus half, minus 4 over 3, plus 1. All of this times pi. So I have what? Pi. Let me do the calculation. 8 plus 4, 12. Minus 1, that will be 11. I have minus 32 over 3. Plus 4 over 3. That give me minus 28 over 3. And then minus half. Okay. Half pi. This is over 6. I have what? 66. 6 over 3 is 2. 2 times 28 will be 56. Minus 3. So that'll give me what? 10 minus 3, 7 pi over 6. That will be the answer. I'm doing it step by step. What we did, if there is the revolution is about the x-axis, huh? If the revolution about the x-axis, this is what we will do. We have r, and we do it everything in terms of x. Now, if the revolution is about y-axis, we want to do it about the y-axis. It will be the same idea, but now we'll do everything in terms of y. So I have r of y, and I have c and d, which is the values of y. Y is between what? And I need to write the function x equal r of y, and then also do the derivative in terms of y. That's the only change. Okay, so the same thing, I sketch, draw a line perpendicular to the rotating line. It will be y-axis or something parallel to the y-axis. At the point y, find a of y, which is by r of y squared. Then also the limits of integration for y, and do the derivative with respect to y. Okay, find the volume of the solid obtained by rotating the region bounded by this. Let me do the graph again, just to show you what's happening. I have y equal 8. This is y equal 8. So we are talking, and x equals 0. X equals 0, it means the y-axis. This is x equals 0, the y-axis. And this is the axis of revolution. It will be the same. The axis of revolution will be the y-axis. So what is my region? This is my region. Okay. And I'm doing the rotation about the y-axis. Okay. If you notice what we did before, this is what will happen always with the disk method. We are doing it by taking the strip perpendicular to the axis of revolution. This is perpendicular to the axis of revolution. To the axis of revolution. Okay. Look at this one. This is the axis of revolution. I'm taking it perpendicular. Same thing. The revolution, I'm taking the line perpendicular. Same thing here. Same thing there. So also the same thing here. I'm doing it perpendicular now. So what I will do, will be my line. That will be my line. And r of y will be what? First, be careful. I want the function to be x equal r of y. So I need to write this. It will be x equal y to the power 1 over 3, which is this function now in terms of x. So r of y will be y to the power 1 over 3 minus 0, which is y to the power 1 over 3. That will be r of y. Okay. So what will be the volume? Will be by. Now I'm thinking about the y values. This is 0. This is 8. Since I will take the lines like this. Okay. So I need to take it this from 0 to 8. So this is the limits of integration from 0 to 8. This is r of y. So I have r of y square dy. That will be dy. Okay. So I have by y to the power 2 over 3. So that means I multiply by 3 over 5, y to the power 5 over 3. Don't forget from 0 to 8. That will be by times what? 3 over 5. This is what? 2 to the power 5. Cube root of 8 is 2. 2 to the power 5. That will be 32. So I have what? 96 by over 5. And that will be the answer. Okay. Another example. Okay. Yeah. Try doing in details, huh? So I'm not going in rush. I'm trying to do it in details. X equal 2 over y, or y equal 2 over x, which is this function. I want it to be between what? Y equal 1 and y equal 4. So we're talking about which region? We're talking about this region. This is the region we're talking about. And I'm making the rotation about what? The y-axis. This will be my axis of rotation. Okay. So since y-axis, I'll deal it with in y. Usually I will make the line perpendicular to the axis of revolution. So I have this. This is will be r of y. Yeah, why not try another color? Yeah, so this is the axis of revolution. So I have r of y is what? Now I have x equal function of y. So it's ready in terms of y. It will be 2 over y minus 0. So it will be 2 over y. It will be 2 over y. Okay. What will be the volume? The volume will be by integral from where to where? I need the y. So I have the lines like this. So I need it from 1 to 4. From 1 to 4. R of y square. So 2 over y square dy. That gives me by 1 to 4. 4 y is minus 2 dy. That gives me by, what is this? Minus 4 over y from 1 to 4. That will be by minus 1 plus 4. So the answer is 3 pi. Okay. Okay. Now we have what? This is x equal y square plus 1. This is parabola. Open to the right. Plus 1. The one. Something like this. This will be between this and the line x equal 3. This is the line x equal 3. This is x equals 3. This is the axis. This is x equals 3. About this line of revolution, about x equals 3. Okay. So we're talking about this area. This is the area we're talking about. Okay. So let me do the line. This is my line. I make it perpendicular to the axis of revolution. That will be my R. So R of y will be what in this case? It will be the line, which is 3 minus the function, which is y squared plus 1. That give me what? 2 minus y squared. That will be R of y. And the limit, to find the limit, I need to find the points of intersection, because it will be this one and this one. So I need to find point of intersection between x equals 3 and the function. So I have what? Y squared will be 2. So y plus or minus square root of 2. So I have my integral. That will be by integral minus square root 2 to square root of 2 of this function square. Of this function square. Okay. So I have what? By integral of this, I have 4 minus 4y squared plus y to the power 4 dy. Very clear, an even function, just to make the calculation easier. Multiply by 2, make it from 0 to square root of 2. Dy. So that gives me what? 2 pi times what? 4y minus 4y cubed over 3 plus y to the power 5 over 5 from 0 to square root of 2. From 0 to square root of 2. Okay, that gives me what? 2 pi. Now make it from 0, that means no need substitute, 0 will be 0. That will be 4 square root of 2. I have what? Y cubed square root of 2 cubed, it will be 2 square root of 2. So that means minus 8 over 3 square root of 2. Here I have what? Square root of 2 to the power 5. Square root of 2 times square root of 2 to the power 4, which is 4. So it will be plus 4 over 5 square root of 2. Okay, so do the calculation. That will be 2 by 2 square root of 2 by, I take square root of 2 out. The remaining is what? 4 minus 8 of 3 plus 4 over 5. Yeah, that gives me what? 2 square root of 2 by. That would be what? 2 square root of 2 by. This one over 15. I have 60. 15 times 4 is 60. 5 times 8 is 40. And then 15, 3 plus 12. So I have what? 2. This is what? 16. 60 minus 40 is 20. Plus 12, 32 times 2. That will be 64 square root of 2 over 50. Okay. Find the volume of the solid obtained by rotating the region bounded by this about the x-axis. Now I'm doing easy questions, but now is it x-axis, y-axis? Now I'm doing the same. It depends. I'm doing the rotation either x-axis like this one or y-axis. Let me see what will happen. Okay. Here I have the function. Here I have the function y equals square root of x and the region from 0 to 4. That will be, I'm doing the rotation about what? The x-axis. So it will be what? When I do the strip or do the line will be perpendicular to the axis of revolution. So that will be this one. So things will be in terms of x. So I'm doing things, not this one, this one, like that in terms of x. Okay. So now what will be r of x? Will be square root of x and square root of x minus 0, which is square root of x. And the region from where to where? From 0 to 4. So the value v will be pi 0 to 4, the volume, square root of x squared dx. That give me what? Pi, this is x, so it will be x squared over 2 from 0 to 4. That will be pi 4 squared 16 over 2, which is 8. So that will be 8 pi. And that will be the answer. The region bounded by this. Y equal e to the power x, which is this one, and y equal 3. Y equal 3. This is not. This is e to the power x. This is e to the power x. I have it at y equal 3. This is y equal 3. And they want to do the revolution about y equal 3. This is my axis of revolution. Okay. So it will be my line. My line will be this one. This will be my line. Since I want it to be perpendicular to the axis of revolution. Okay, so things will be in terms of x. So r of x will be what? 3 minus e to the power x, which is the length of this line. 3 minus e to the power x. So it will be the volume. The volume will be pi integral from 0. Now this is 0 to what? X values. 0. Here it's starting from 0. From 0 until this point. This point will be what? The intersection between the two functions. So point of intersection will be ex equal 3. So I have x equal length 3. Okay, so it will be 0 to length 3 of this 3 minus ax squared dx. Okay. Now let me do the calculation. That will be by, what is this? 9 minus 6 e to the power x plus e to the power 2x dx. So that give me by 9x minus 6ax plus half e to x from 0 to length 3. Be careful. Now the 0 we have values, huh? So now let me do the calculation. By I have 9 length 3 e to the power length 3. This is 3 times 6. That will be 18. E to the power 2 length 3. That e to the power length 3 squared, which is 9. So that will be plus 9 over 2. Okay, this is the first one. Minus. When I substitute the 0, 9 times 0 is 0. E to the power 0 is 1. Be careful. That will be minus 6 plus half. Now, let me finish the calculation. I have 9 then 3. I have minus 18 plus 6. That is minus 12. I have 9 over 2 minus half. That will be plus 4. So the answer is by 9 then 3 minus 8, which is positive. Yeah, volume should be positive. Always should be positive. Sometimes he doesn't want you to do the calculation, only set up the integral. only to set up the integral. Okay. So let me do it here. Now, what is this? I have y equal ax, and the same thing, y equal 3. But I'm doing the revolution about what? About the y-axis. Huh? So this is y equal x. This is y equal 1. I'm talking about this area. Okay. But I want to do it about the y-axis. The previous one is about the line y equal 3. Now it's about the y-axis. So this is my axis of revolution. Okay. So how I will do the line? The line will be this way. This is the line. I want it to be perpendicular to the axis of revolution. So this is will be my line. So it means I need to write everything in terms of y, not in terms of x. So I have y equal ln x. It means x equal ln y. Okay. So it will be r of y will be the length of this line, which is the function, which is now in terms of x. In terms of y, I mean ln y minus, here I have y equals 0. Huh? So ln y minus 0, which is ln y. Here I have x equals 0, sorry. X equals 0. So I have here the function x equal ln y. I change the function. You make it y as a function of x? No, I want it to be x as a function of y. Okay, so what will be the volume? And from where to where? From where to where? From this point, the y values. I'm talking about the y values. So it's from here, since I'm doing the lines like this. Huh? This is the line, y equals 3. Okay, so I have it from here, which is 1. Here I have y equal 1. Here I have y equals 3. Okay, so the volume will be by 1 to 3 r of y square, which is ln y square dy. That's it. This is what he wants. He wants to only set up the integral. No need to solve it. Find the volume. Find the volume means we need to do the calculation. Yeah, from here it seems to be the calculations are complicated, but it's okay. Let us see what will happen. First, I need to graph the function. Yeah, also the function is not an easy one to graph. That will be x. I take y square. I have 4 minus y. It means at x, y equals 0, y equals 4, x will be 0. So I have this function, which is a little bit strange. So here I have 0. Here I have 0. 0 and 4. Okay, to find the region now. Okay. If x is less than 0, x is less than 0, negative. Yeah, if x goes to negative, y will be negative. No. If x is positive here, so y will be, if x is positive, this is the x-axis, y-axis. Yes, I can have it, okay. So if x is positive, then y should be, yeah, something between, yeah, y cannot be less than 4. If x is positive, so it will do something like this. Okay. Why is negative is okay, huh? If y is negative, then x is positive. If y is negative, then x is positive. We'll do something like this. Now, between 0 and 4, when y is between 0 and 4, then x will be positive. So it will do something like this. And then if y is greater than 4, then x will be negative. It will be something like this. The area which we are talking about is this area. This is the area we're talking about. Okay. And what is the axis? And this is x equals 0, so the y-axis. So this is the area bounded between the y-axis and the function, which is this is the function. Okay. About the y-axis, so this is my axis of revolution. So that means my line should be perpendicular to this, so it will be like this. That will be my line. So what I will do, I will make the calculation now this way. Now r of y will be what? The function minus 0, which is 4y squared minus y cubed. Okay, what will be the volume? Will be by, what is the limit of integration? Y هنا y equals 0 to y equal 4. This is the area I'm talking about. Okay. So from 0 to 4 of this, 4y squared minus y cubed square. I have my r squared. This is my r of y. I need to square it. Okay, now we'll do the calculation. 0 to 4, that will be what? Yeah, 16 y to the power 4 minus 8 y to the power 5 plus y to the power 6 dy. Yeah, that give me what? By 16 y to the power 5 over 5 minus 8 y to the power 6 over 6. So it will be minus 4 over 3 y to the power 6 plus y to the power 7 over 7. From where to where? From 0 to 4. Okay, that give me by, I'll do the calculation, 16 4 to the power 5 over 5 minus 4 to the power 6 over 3 minus 4 to the power 7 over 7. I notice one thing. This is 16, which is 4 square. So I have 4 to the power 7. I can take it as a common factor. 4 to the power 7 times pi. The remaining is what? 1 over 5 minus 1 over 3 minus 1 over 7. Plus, this is plus y minus. This is plus, sorry. That give me what? Pi 4 to the power 7. This is what? 105. Common factor. So I have 21 here. 105 over 5, that will be 3 times 7, which is 21. 105 multiplied by 5 by 7, just do calculation. This will be 35, which is 5 times 7. This is 15, plus 15. So the answer is what? By, this is 21 plus 15, 36 minus 30, that will be 1. 4 to the power 7 over 105. If we do the calculator, 16384 by over 105. Okay. That will lead us to the washer cases. What's the difference now in the washer? I have the region is not over the axis. The region is something between two regions. It's bounded between two regions. And what is the idea? The idea is very simple. I will find or do the bigger region like R of X, bigger R, minus the small r, using the same formula. So I draw a line perpendicular, rotating line, and then I have formula for the area. The area will be what? By R square, capital R square, minus small r square. Okay. So this will be the idea. I have the bigger outer radius and I have the inner radius. So I need to do like I'm doing the bigger one minus the small one. So the outer radius will deal with the capital R and the inner radius I have with the small r. And then I have the limits of integration, the same thing. From x equal 8 between a and b, then I will do the volume. For the y cases, it will be the same idea, but now in terms of y. Okay, let me do one example. Okay, find the values revolving the region bounded by the graphs. The graph is here, but let me do it again to see it from scratch. Okay, this is y equals square root of x. That is y equals square root of x. And that is y equal x squared. Okay. Now when I do, and this will be the axis about the x-axis. I want it to be about the x-axis. Okay. The same idea, we'll do the line. But I have outer radius and inner radius. What will be the outer radius? Capital R will be this function, the bigger one, which is square root of x. The inner radius will be this function, which is x squared, which is x squared. Okay. So what will be the area? Let me do the area. Will be by r of x square minus small r of x square, which is this one. This will be the area. So do the calculation by x minus x square minus x to the power 4. No, it's not x squared, it's x to the power 4. And from where to where? Just equate them. Square root of x equal x squared. So I have x equal x to the power 4. So I have what? X to the power 4 minus x equals 0. Like x, I have x cubed minus 1 equals 0. So I have x equals 0 or x equal 1. So I have 0 and 1, the x values. So the value will be the integral. I have the pi here. 0 to 1. This one. R of x squared, which is x, minus x to the power 4, dx. Do the calculation. That will give me what? By x squared over 2, x to the power 5 over 5, from 0 to 1. That will be by half minus 1 over 5. That give me what? By 2 over 10, 5 minus 2. And that give me 3 pi over 10. Okay. Y equal x squared plus 1. Find the graph y equal x squared plus 1, y equal 0, x equal 0, and x equal 1. Now the region. First, we need to see the region. That will be the region. Then we'll do the calculation. Okay. Now I need to do the region first. What will be the region? The region will be y equal x squared plus 1, which is this. Is y equal x squared plus 1 about what? Y equals 0, which is the x-axis. This is y equals 0. Okay, x equals 0, which is the y-axis. And x equal 1. X equal 1. So this is my region. Okay, and you want it about what? about the y-axis. So this is my axis of revolution. So when I do, yeah, this is a little bit different. So this is the green one. So this will be the line. But be careful. I have two lines. I have two places because the line here is different than the line here. Okay, it means what? I need to find two different volumes. Okay, so I need to find two different volumes. Volume will come from this region, and volume will come from this region. Be careful about that. So let me call it V1, and this is called it V2. Okay, V1, I have what? Let me just, well, this is a little bit complicated example. Let me use a different color. So I have, this is a region, and this is another region. Okay, I hope it's clear. Okay, so for V1, now for V1, I have what? What will be, yeah, for V1, I have R of Y, will be the outer will be this one, and the function will be the inner. R of Y for V1, R of Y equal 1, and for the small, in terms of Y, everything is in terms of Y. The small one, I have square root. From here, I need to write the function x equal. So I have x squared equal y minus 1. So x equal plus or minus square root y minus 1. But I need the positive side. So it will be square root y minus 1. Okay. Now, from where to where? Yeah, I need to find this point. And the line is x equal 1. So they have the intersection between x equal 1 and x equal square root y minus 1 for y. Very clear. If you equate them, I have y equal 2. 1 equal y minus 1, so y equal 2. So this is, here it's 1. So I'm talking about for V1 from 1 to 2. From 1 to 2. The other one from 0 to 1. I will come to that. Okay, so the integral V will be by from 1 to 2. I started with the difficult one of what? 1 square minus square root y minus 1 square dy. Let us do the calculations quickly. That give me what? By from 1 to 2, I have 1 minus y plus 1. So that give me 2 minus y dy. So that is what? That is 2y, don't forget the by. 2y minus y squared over 2 from 1 to 2. And that give me by times what? 4, 2 square 4 minus 2 minus 2 minus half. Okay, that give me what? Half. So this is pi over 2. Now for V2, from 0 to 1, which is this area. Now I have only this line. So it's only disk, it's not washer. I don't have two functions. I have only one function, which is x equal 1. So capital R of y is 1. Okay, 1 minus 0, which is 1. So the volume and the V1, V2 will be by integral from 0 to 1 of 1 square dy. which is pi times y from 0 to 1, which is pi. What will be the volume? It will be V1 plus V2, which is what? Pi over 2 plus pi, which is 3 pi over 2. Okay. That was a little bit complicated. Actually, the same problem we will do using the shell method in 7.3, which will be easier. When the shell method will take the line perpendicular to the, not perpendicular, parallel to the line, parallel to the axis of revolution. If you make it parallel, I have only one function. No problem. Okay, let me do one problem, then I will stop. Okay. Yeah, or two problems. Okay, I'm close by the curves. Huh? I need to draw the curve first. That will be the curve. Y equal x. This is y equal x. Y equal x square. This is y equal x square. And I want to rotate it about what? The x-axis. This is my axis of revolution. Okay, let me draw the line. Okay, this is my area. So the line, I want it to be perpendicular to the axis of revolution. So I have this line. This is my line. So I have capital R of x will be what? The upper, which is x, and small r of x, which is x squared. That will be x, and that will be x squared. So that will be the volume, will be pi from where to where? I need this point. How to get this point? I have x equal x squared, which I know that x will be 0 or x is equal to 1. So it's from 0 to 1, capital R square minus small r square. That give me pi. This will be x square, x cube over 3, minus x to the power 5 over 5. Okay. Okay. That give me what? Pi from 0 to 1, huh? Yes. 1 over 3 minus 1 over 5. That give me 2 pi over 15. Okay. I will stop the recording, and I will do more problems later. I hope this one we cover a good number of problems. Let me stop the recording. Thank you.